Spectrophotometer.
Hello amigos, we're back for video 2, and these are our three, what are they called? Yeah, we got 3 of them. Yeah. And now we're going to transfer them into the cuvette, or separations, and we're going to transfer not an excess amount, and we're just going to transfer enough. And as I'm doing that, he's filling up the water cuvette, and then here is our first cuvette filled up with enough but not excess.
And I'm about to start on the second one.
And while he does that, I'm going to dilute the first one with water up to the line. You feel me?
One more drop of this.
Now we're going to dilute them with water. The meniscus is slightly below the line, so we're going to add a few more drops to get it above the line. Now the bottom of the meniscus is sitting on the line.
Now I will dilute to the line on the second one.
Yep, and now we're going to take our cuvettes, we're going to take them to the lab, and then we're going to lock in. You feel me?
Spectrophotometer time.
First thing we'll do is wipe down the side of the cuvette with the arrow and the corresponding side behind it so that it is clean and does not affect the absorbance. And this is our blank cuvette that we would use to zero out the spectrophotometer. And so then we're going to open up the spectrophotometer, and we're going to make sure the arrow is facing the light. And we're going to close it, and then we're going to get on the computer, and we're going to click 0, but we're going to click connect first. We're going to go click setup. We're going to go make sure it's 800 to 200, and it in fact is, so now we're going to go press OK, and then we're going to press 0, press OK. And now that it is zeroed out, we're going to open up our spectrophotometer and take out our blank slide. And then we're going to clean off our first blue color, the sides corresponding with that arrow and the one behind it on the blue cuvette, and we will place that in our spectrophotometer. With the arrow facing the light. And then we're going to close it before we scan. And then we're going to go up to the top and we're going to click start. No spaces.
No spaces.
Just if you do the first 2 times, we're going to get blue deleted. And since that name worked, we're going to click OK, and we're going to watch the absorbance go crazy. Now, we are going to record the absorbance of the sample. You feel me? Now we will repeat the process by wiping off the cuvette on the 2 sides of the left to prevent any absorbance issues. We're going to open the spectrophotometer and enter it with the triangle facing the light. Now we're going to close the spectrophotometer. We're going to close out our burst graph.
No, it's
And we are going
I will say
to...
though, honest lab is way easier than non-lab actually. It's ridiculously different, but it's easier.
We report?
The practicals are maybe a little bit harder, but like not even. We did titration for practicals. I think I'll do titration just for anyway. Like, you ever thought of this? You do? What time?
5 to 6:15.
Perfect.
What class is it?
And then we click record.
Ew!
I'm dead.
With the
Ew!
sheet name.
I'm so sorry. I didn't know
And now we're going to record the blue absorbance data. Okay. So we scan across all wavelengths. 1, so we can identify the compound, and then 2, so we can match the graphs once we get back to the lab. And then we find the peak, so when we use it later, we know where to get the most accurate results. And that's why we scan across all wavelengths. And then the lambda max is the peak, where it's like the max absorbance. And then the Beer-Lambert law, the rule, is absorbance equals the molar coefficient times the distance the light travels, which is 1 centimeter in this case because it's the width of the cuvette, and then times the concentration, which is the amount of absorbing substance in the solution. And the absorbance concentration relationship is a direct linear relationship, and we zero it out because it corrects for background absorbance and prevents absorbance from being higher than normal, and everything, all the values are going to be higher if you don't zero it out because your absorbance is going to be messed up. And I think that's all.
Feel free to pause the video at any point to check out these pages in the notebook. Time to clean.
We threw away our pipettes in the trash, and now we're going to pour the solvent in the waste.
Oh, that one's pretty. Best pop-off Steve approved. Best pop-off Steve approved.
Now we're cleaning our beakers with soap and water.